Good afternoon, everyone. We are group number 8 and we are going to discuss about the chemical safety. I am Jeric James P. Pascual, together with my group members, Alexis Dasigao, Cherish May Donato, Joshua Ladovice, Roxanne May Pagirigan, and John Ray Pilar. So for our table of contents, we have 6, and that includes introduction, container labeling and posting, health and chemical hazards, safety data sheet, chemical waste disposal, and the summary. For the introduction, we need to know why do we need to study chemical safety and its importance. So the objective of this topic is to explain the importance of chemical safety and to distinguish the roots of chemicals and types of chemical hazards and use the safety data sheet. The importance of chemical safety is to prevent exposure from chemicals that may lead to potential hazards. It is used for us to prevent any accidents that might happen due to the chemicals being used in a facility and to develop attitude towards safety and acquire habit of assessing hazards and risks. So it is to assess any hazards and risks and make sure that our workers will have a safe working environment. For the routes of entry of chemicals, we have 3 ways, and that is thermal exposure, inhalation, and ingestion. To know more about these 3, I am going to discuss them one by one. For the thermal exposure, toxicity is the chemical depends on the degree of absorption that occurs when it penetrates the skin. So the organic chemicals are much more likely to penetrate the skin than inorganic chemicals. It can cause mild temporary discomfort to permanent skin damage. So chemical compounds are those obtained directly or indirectly from plants and animals. The compounds obtained from minerals are known as inorganic compounds. So the examples of organic molecules are fats, nucleic acid, carbohydrates, enzymes, proteins, and hydrocarbon fuels. And for the inorganic compounds, we have nonmetals, salts, metals, acids, bases, and things derived from a single element. Those are the examples of inorganic compounds. So for the inhalation, chemicals in the form of gases, mists, vapors, fumes, and dusts entering through the nose, trachea, bronchi, and lungs. These particles from chemicals in the form of gases, vapors, and mists can damage the lung surface. That's why a mask is a very important equipment inside a facility. So for the ingestion, this involves chemicals entering through the mouth into the gastrointestinal system. These include chemical dust, particles, and mists that are inhaled through the mouth and swallowed or which have contaminated objects such as hands, food, and cigarettes that come in contact with the mouth. That is why food and drinks and cigarettes are not allowed inside the facility. So that is all in the introduction, and we're going to move on to our second topic, which is the container labeling and postings that will be discussed by Joshua Ladovice. Thank you.
Container labeling. Chemicals that are contained in a container must have a way to identify them. That's why labels are used to identify chemicals that are hazardous and its risk and how to avoid them. Labels are also necessary for a container to ensure that the chemical will be stored and disposed properly. When handling containers that has the original or manufacturer label of the chemical, the container must have these 6 required label elements that can be seen clearly. First is the product identifier. This is the chemical name, code number, and the batch number of the product. Second is the supplier information. It includes the name of the company that manufactured the chemical, the address of the company, and its telephone number. Third is the signal word. It will show the severity of the hazard. There are only 2 words that is used for signal words. These words are danger and warning. Within a specific hazard class, the word danger is used for more severe hazards, while warning is used for the less severe hazards. Fourth is pictograms that will show the chemical is hazardous. Fifth is the hazard statement, where it describes the effect of the chemical when exposed to a person. Lastly is the precautionary statements, where it describes the recommended steps that should be taken to decrease or prevent adverse effects resulting from exposure to the hazardous chemical or improper storage or handling. These are four types of precautionary statements. First is prevention, which serves as a guide to lessen the exposure of the chemical. Second is the response, which is the steps when the person is exposed to the chemical. Third is the proper storage and of the chemical. Lastly, the disposal of the chemical. When transferring chemicals into a secondary container, it is necessary to have a label to prevent misuse of the chemical and its potential hazard. When labeling containers that hold more than 50 milliliters of chemicals, the labeling should include: first is the name of the chemical, also its chemical formula; second is the hazard warning; third is the hazard pictogram; and lastly, the date when the chemical was prepared. While labeling small containers such as test tubes or vials, the labeling should include the acronym of the chemical formula of the chemical and the pictogram of the hazard of the chemical. Safety posters. Safety signs help people in a workplace by guiding them on what are the do's and the don'ts while handling chemicals and other substances. Placing these safety signs throughout the workplace will increase the prevention of accidents and maintaining a safe workplace. These are the examples of safety signages. First example is the personal protective equipment or PPE signages. These signs are belong to the physical safety signs, where it is used to guide people to wear the appropriate personal protective equipment in the workplace when handling chemicals that have potential hazards. When wearing laboratory coats, safety goggles, face masks, and gloves will increase the prevention of chemical exposure on our body. Second example is the no open flame sign. This is a fire safety sign used to give awareness to the people in a workplace to not use open flame devices such as lighters in an area where chemicals and other substances are prone to catch fire easily. This safety sign will prohibit people from using open flame devices to prevent unintentional fire accidents. Last is the glassware hazard sign. This is a hazard sign used to tell a person in a workplace that there is broken glass in an area. Broken glass is a physical hazard, but it can also pose a health risk if it is polluted with harmful chemicals or infectious substances. That is all for the container labeling and postings. To know more about hazards, this will be discussed by Mr. John Ray Pilar.
Health and chemical hazards. Health hazards are chemical, physical, or biological factors in our environment that can have negative impact on our short or long-term health. Exposure can occur through touch, inhalation, and ingestion. Exposure to chemicals can pose significant health standard to people, specifically in the workplace or environment. Chemical exposure can cause a wide range of health effects, from minor symptoms such as skin irritation and headaches, to more severe conditions such as cancer, neurological disorder, and reproductive problems. While chemical hazards can cause acute or chronic negative health effects from short or long-term exposure, these chemicals are found in outdoor or indoor environments, including the home, workplace, and schools. Chemical hazards refers to the potential danger posed by chemical to people, the environment, and property. These hazards can include exposure to toxic, flammable, corrosive, or explosive chemicals. Chemical hazard can also include environmental hazards such as pollution and contamination of air, water, and soil. This risk of chemical hazard can be mitigated by the following proper safety protocols and regulations when handling and storing and disposing of chemicals. Types of chemical hazards. Toxicity. Toxicity is the degree to which a substance can cause harm to living organisms. Exposure to these toxic substances can lead to a wide range of health problems, from acute symptoms like nausea and headaches to chronic conditions like cancer and neurological disorders. Sample of toxic substances can include heavy metals like lead and mercury, pesticides and herbicides, and certain chemicals found in cleaning products and industrial processes. Irritant. Irritant is a substance that causes inflammation, redness, or swelling when it comes into contact with the skin, eyes, or respiratory system. Common examples of irritants include certain plants like poison ivy and poison oak, some chemical found in cleaning products and cosmetics, and airborne particles like dust and pollen. Prolonged exposure to irritants can lead to chronic conditions like asthma or dermatitis. Next is flammable. Flammable substance is one that can easily catch fire and burn when exposed to heat, sparks, or flames. Example of flammable materials include gasoline, propane, alcohol, and some cleaning solvents. Flammable substances can be dangerous if not handled and stored properly and can cause fire that can spread quickly and cause extensive damage. The next is corrosive. A chemical is defined as corrosive if it causes visible destruction of or irreversible alteration in living tissue by chemical action at the site of contact. The corrosive substance is one that can cause damage to materials or living tissues through chemical reactions. Examples of corrosive materials include strong acids like hydrochloric acid and sulfuric acid, strong bases like sodium hydroxide and potassium hydroxides, and some cleaning agents. Corrosive substances can cause severe burns or tissue damage upon contact and can also damage equipment and infrastructure over time. The next is the inhalation. Inhaling chemicals can lead to harmful effects on the body, especially to the lungs and respiratory system, as they can be absorbed directly into the bloodstream. Examples of harmful chemicals that can be inhaled include pollutants from cars, industrial activities, tobacco smokes, and volatile organic compounds or VOCs from paints and solvents. Protective measures such as wearing masks and proper ventilation can help minimize the risk associated with inhaling these chemicals. Next is ingestion. Ingesting chemicals can cause severe harm to the body, particularly to the digestive system and other organs such as the liver and kidneys. Example of harmful chemicals that can be ingested including cleaning products, pesticides, lead, and other heavy metals, and certain medication when taken in excess. Proper labeling, storage, and disposal of these chemicals, as well as using them only as directed, can help prevent accidental ingestion and associated health risks. Next is environmental hazards. An environmental hazard is a substance or phenomenon that can cause harm to the natural environment and or living organism. These hazards can have far-reaching effects on ecosystem and can lead to health problems in humans and wildlife. Examples of environmental hazard includes air pollution from factories and vehicles, water pollution from agricultural runoff and sewage, and the release of toxic chemicals into the soil. Lastly is the reactive. Reactive chemicals can pose significant hazard due to their potential to cause violent reaction when exposed to certain conditions or substances. Examples of reactive chemicals include peroxide, chlorides, and nitrates. Proper storage and handling of reactive chemicals, as well as careful monitoring and identification of potential reactive hazards, are essential to prevent accident and ensure safety in the workplace. Safe handling of chemicals. Safe handling of chemicals is essential to protect the health and safety of workers, the public, and the environment. Proper training and education are necessary to ensure that workers are aware of the hazard and the risk associated with the chemicals they are handling, as well as the appropriate safety protocols to follow. This includes the use of personal protective equipment, proper storage and segregation of chemicals, and appropriate labeling and signage. Regular inspection and maintenance of equipment and storage are also necessary to ensure that chemicals are stored safely and securely. In case of spills or accident, it is essential to have emergency response plan in place and to conduct regular drills and training to ensure that workers are prepared to respond quickly and appropriately. It is essential to follow proper safety protocols and regulations when handling chemicals to minimize the risk of exposure and protect the health workers and the public. Storage and segregation. Proper chemical storage is required to minimize the hazards, associated leaks and spills, accidental mixing of incompatible chemicals. Proper storage and segregation of chemicals is essential to ensure safety in the workplace and prevent harm to people and the environment. Chemicals should be stored in designated areas that are well ventilated and free from heat sources, direct sunlight, and moisture. It is also important to keep incompatible chemicals separate from each other to prevent reactions and ensure that containers are clearly labeled with information in their contents and hazards. Proper signage should also be used to identify chemical storage areas and to provide emergency information in case of spills or accident. Regular inspection and maintenance of storage areas are also necessary to ensure that chemicals are stored safely and securely and to address any potential hazards or risks. Examples of incompatible chemicals include acids and bases, oxidizing agents and reducing agents, flammable and combustible substances. Transporting hazardous chemicals. Transporting chemicals can be one of the riskiest procedures carried out because at no other time is accidental release and exposure more likely. However, by using the same care and caution before and during transportation that one would any experimental procedure, danger to oneself, others, and the environment can be minimized. Transporting hazardous chemicals requires proper planning, equipment, and training to ensure the safe and secure transportation of these materials. Examples of hazardous chemicals that may require special transportation precaution includes explosives, flammable gases and liquids, corrosive substances, and toxic materials. Regulations and guidelines such as the United Nations Model Regulation for the Transport of Dangerous Goods, provide guidance on proper transportation practices, including packaging, labeling, and documentation requirements. Transport vehicles should be properly maintained and equipped with safety features like fire extinguishers, spill kits, and emergency response equipment. Drivers and handlers should also be trained on the specific hazards and risks associated with the chemicals being transported and be aware of emergency response procedures in case of accident or spills.
Safety data sheets. Safety data sheets are documents containing hazard and safe handling information that is prepared in accordance with the requirements of the Hazard Communication Standard. The SDS help us to conduct chemical risk assessment around the workplace and ensure that each area is safe for work. In accordance with the Globally Harmonized System or the GHS for classification and labeling, safety data sheets should contain a predefined set of sections with specific information.
Requirements. Each work area is responsible for ensuring that all personnel have access to a paper or electronic copy of SDS for all hazardous chemicals used and stored in their immediate area during all work shifts, meaning that everyone in the workplace should be aware of what kind of chemical they are working with. SDS is important because users or workers may obtain information about a product's hazard, how to use it properly, what to expect if the precautions are not followed, how to notice the exposure symptoms, and what to do in case of emergency.
There are 16 sections for the safety data sheets. Section 1. Identification. This is where you find out the actual product name and the typical uses of the substance. It should also give you the names and the contact details of the manufacturer or the producer of the substances. This is an example for Wild Spanish Marjoram Essential Oil. Section 2. Composition or the information on ingredients. It identifies the ingredients contained in the product indicated on the SDS, including impurities and stabilizing additives. So this section includes information on substances, mixtures, and all chemicals were at trade secret is claimed. Section 3. Hazard Identification. It gives us more specific insight into the harmful impacts that may be caused by a substance. For our Wild Spanish Marjoram Essential Oil example, there are a couple of hazard identification that sum up the risk. So we can see that the substance may cause severe skin and eye irritation, and also inhalation may cause irritation. Section 4. First aid measures. In this part, it usually the main crux of the information. These are the immediate response protocol that are recommended in the event of a specific types of exposure. We are dealing with a liquid in solution in this instance. So the main routes of exposure or entry to the body are going to be contact with eyes and skin or via ingestion or swallowing of the substance. The first aid measures section should tell us what our appointed first responders should do to help the affected person. For example, in case of eye contact, in case of skin contact, in case of ingestion, or if it is inhaled. So, this is important when considering what amenities we have available in the vicinity of the work area. Section 5. Firefighting measures. In this section, we see the recommendation for using extinguishing media in the event of a fire. Our main concern is going to the potential from contact with the product and hazardous gases that may be created in the event of fire. So, in other words, this section will provide us with a specific information on the suitable extinguishing media to be used. Section 6. Accidental release measures. It provides recommendation on the appropriate response to spill, leaks, or releases, including containment and cleanup practices to prevent or minimize exposure to people, properties, or the environment. It may also include recommendation distinguishing between responses for large and small spills, where the spill volume has a significant impact on the hazard. Section 7. Handling and Storage. It provides guidance on the safe handling practices and conditions for safe storage of chemical, including incompatibilities. So, all products to be stored must be classified in the storage class relevant to their specific hazard characteristics. Section 8. Exposure Control and Personal Protection. So, this is one of the most important sections for our safety data sheets, which outline the necessary exposure control and personal protection. It indicates the exposure limits, engineering controls, and the personal protective equipment or the PPE measures that can be used to minimize worker exposure.
Section 9. Physical and Chemical Properties. In this section, it identifies the physical and chemical properties associated with the substance or mixtures. It includes the appearance of the chemical, like its color and density. It also includes the odor, freezing or melting point, and the viscosity. Section 10. Stability and reactivity. This section describes the reactivity hazards of the chemical and chemical stability information. This section is broken into two parts. The first is reactivity, and the second one is chemical stability. Reactivity is a description of chemical-specific test results if such data sufficiently represent the probable hazard of the chemical. If available, they may be for a class or family of the chemical. Chemical stability indicates a chemical stability or instability at the standard ambient temperatures and pressures while being handled and stored. It also describes any stabilizer that might be required to keep the chemical stability. Section 11. Toxicology Information. This section identifies the toxicological and health effects information or indicate that such data are not available. It consists of the information about the probable exposure routes, inhalation, ingestion, skin, and eye contact. It also includes description of short and long-term exposures, chronic, delayed, or acute effects, description of the symptoms. This description includes symptoms related to chemical exposure, ranging from the mildest to the most severe exposure. Section 12. Ecological Information. This section provides information to evaluate the environmental impact of the chemicals if it were released to the environment. It says whether there is a possibility that the chemical will stay in the environment and break down either through biodegradation or other processes such as oxidation and hydrolysis. Possibility of chemical getting into groundwater from the earth. Possible negative outcomes. For the example is environmental fate, potential for ozone layer thinning, and potential for photochemical and ozone production. Section 13. Disposal Considerations. This section provides guidance on proper disposal practices, recycling reclamation of the chemicals or its container, and safe handling practices. Example, it must not be disposed together with household garbage. Do not allow products to reach the sewage system. Observe all federal and state and local environment regulation when disposing of this material. Section 14. Transport information. This section provides guidance on classification information for shipping and transporting hazardous chemicals by road, air, rail, or sea. It includes the transport hazard and any additional safety measures that an employee should be aware or follow when traveling by vehicle inside or outside of their workplace. Section 15. Regulatory information. In this section, it identifies the safety, health, and environmental regulations specific for the product that is not indicated anywhere in STS. Any information on local, national, and international about the chemical or combination regulations. Section 16. Other informations. This section states when the STS was prepared or when was the last null adjustment was made. The STS may additionally identify where the modifications have been made prior to prior addition. You could also contact the supplier for clarification of the changes.
Good day, everyone. My name is Alexis Dasigo, and I'm here to discuss about chemical waste disposal. Before we proceed to our main topic, let's have a brief discussion about what chemical waste is. So what is chemical waste? Any solid, liquid, or gaseous waste items that could significantly endanger human health and the environment if poorly handled or disposed of qualifies as a chemical waste. In other words, chemical waste is any unnecessary or excess use of a chemical or a chemical substance that could harm human health or the environment when released to the air, water, or land. Examples of chemical waste include, but are not limited to, the following: batteries, pesticides, fluorescent light bulbs, dye, glazes, and many more. So how are we going to dispose our chemical waste properly? First, we must store chemical waste in appropriate containers. Plastic bottles are preferred over glass for storing hazardous waste when compatibility is not an issue. Segregate chemical waste by compatibility and not alphabetically. Second, chemical waste containers must be labeled with the following information. First info is full chemical name and quantity of the waste. For mixtures, each chemical must be listed. Abbreviations, acronyms, and dito marks to replace words are not allowed, as this does not comply with the hazard communication standard. Next is the date of waste generation. Third is the place of origin. Fourth is the principal investigator's name and telephone number. Fifth is the bottle number assigned on corresponding waste sheet. And lastly, the tag or label must have the words hazardous waste. So next, let's us discuss about chemical waste labels. So how to label chemical waste? First, fill up the name, address, and contact number of the generator. The generator is the person who is filling out the waste label, not the lab group or principal investigator or PI, unless the PI is filling out the waste label. Second, date the label with the date that the waste is first added. Next, fill in building, room number, and telephone number where the person who is filling out the waste label can be reached. Next, circle the appropriate waste streams or write it in. Next is list each waste constituent. Down to 1% heavy metals must be listed down to the parts per million range. Label contents must add up to 100%. Volumes are acceptable. Use only common chemical names or IUPAC nomenclature when listing the chemical constituents on the label. Do not use abbreviations, chemical symbols, or trade names. And next is check all the hazards that the chemical waste may cause. For selecting a container for chemical waste, for liquid chemical waste like bulk solvent and aqueous liquid waste streams, use a low-density polyethylene nalgene container. And for bulk corrosive liquid waste streams, Use the just right safety containers for waste disposal. Just a note, do not use glass, plastic-coated glass or other reused reagent chemical bottles to store or accumulate bulk liquid chemical waste. Do not use containers that are old, dented, damaged, leaking, or cracked. The container must be able to be capped, sealed, or closed. The container must be compatible with the waste streams that will be placed in it. For laboratory cleanout of reagent chemicals, all laboratories should, based on the hazards they pose, inspect all of the reagent chemicals. Look for chemicals that are no longer needed, old and out of date or unusable. Try to redistribute unneeded chemicals around the department or building. If no one else needs the chemical or if they are out of date or unusable, then package them as follows. Package by hazard class in sturdy cardboard boxes. Use sufficient packing material to prevent container damage en route. And lastly, place a completed chemical waste label and packing slip on the outside of the box. Next, for sealed vials or those who are sealed 15 ml or less, some laboratories generate a number of sealed sample vials. If the laboratory does not want to reuse the glassware or plasticware and does not want to empty the contents into a liquid chemical waste container, the following procedures must be followed. First, obtain a clean 5-gallon polyethylene pail with lid. Next is line the pail with heavy-duty plastic bag. Next, place a chemical waste label on the outside of the pail. Place only compatible material in pail. Next is place the lid on the pail. And lastly, when full, tightly seal bag with tape or bag closure tie. Next is for solid waste streams. Solid waste includes any laboratory material that has come in contact with a chemical or is potentially contaminated with a chemical. Examples include gloves, benchtop paper, weighing boats and papers, paper towels, cleanup material, and permanently contaminated glassware and plasticware. For solid waste streams, use 5-gallon poly pails, cardboard boxes, or other sturdy containers. Next, all containers must have lids. Apply a completed chemical waste label on the outside of the container or in vinyl tags attached to the containers. Next, line the container with a 7mm polyethylene bag or 3 standard trash bags. Next, all bags must be sealed unless laboratory personnel are actively adding waste. Seal the bag with a bag closure tie or a large binder clip. When the container is full, seal the bag with tape. If the container is in cardboard box, secure the box with tape as well. Last, it is important not to overload containers. Full boxes should not weigh more than 40 pounds. Do not use overly large boxes. Only fill boxes 2/3 full if they contain broken glass. Next, for chemically contaminated sharps. Anything that is capable of cutting or puncturing must be managed in sharps container. Examples of sharps include needles, syringes, razor blades, slides, scalpels, pipettes, broken plastic or glassware, micropipettes, and pipette tips. If a sharp is chemically contaminated, simply place it in a sharp container that is labeled with a properly filled out orange chemical waste label, which means it is a biohazardous waste. For empty chemical containers. Empty chemical containers are still hazardous to the university personnel and the environment until they are properly managed. Below is the summary of steps required to make empty chemical containers safe for disposal. First, triple rinse with copious amounts of water. Collect the first rinse as chemical waste, and rinse 2 and 3 can go down to the sanitary sewer. Next, place a label over the original container label or deface the label. Do not replace the cap on the container. Place empty or triple rinse containers in a glass-only box, recycling container, or directly into the dumpster. And next, for clean, uncontaminated broken glassware. In an effort to minimize the amount of chemical waste generated, uncontaminated glassware and plasticware should not be managed as waste. Unwanted, clean, non-broken glassware and plasticware can be packaged up by the laboratory personnel and taken to the dumpster or recycling area. Broken glassware and plasticware creates a potential hazard, so special procedures are needed. First, reuse a heavy corrugated cardboard box lined with plastic liner. construct the boxes per directions, tape the bottom, and when the container is 3/4 full, seal and take to the dumpster yourself. Just remember that you must wear personal protective equipment or PPE while handling these boxes. Next is the things that you should do when adding waste to a container. First, waste can be added only after you choose the proper container and if it is labeled. The minimum personal protective equipment or PPE may be dictated in the chemical hygiene plan. If not, all personnel working with chemical waste must wear the following: safety goggles, splash goggles if working with liquid waste, lab coat, and gloves that is specific for the compounds in use. So what are the things that you need to do for when adding liquid chemical waste to a container? First, perform liquid chemical waste management in a fume hood. Next, check the container label to assure that waste is being added to the correct container. The container must be in secondary containment like large plastic bin or bucket. Next is uncap the container. Use a funnel sufficient for the size of the container and volume of waste being added. Slowly add the waste, watching for any unintended reactions. If you observe a reaction, immediately stop adding the waste, close the fume hood sash, and contact Environmental Health Services or EHS. After the waste has been added, remove the funnel and seal the container with a cap. Next, for adding solid waste in a container. First, obtain and label a proper container. Open the lid to the container and unseal the bag. Add the waste, seal the bag with a bag closure tie or large binder clip, and then reseal the lid. So why are we discussing chemical waste disposal? We're discussing chemical waste disposal to avoid or prevent common laboratory violations like this. First is unknown unlabeled chemical waste, mixing or storage of incompatible chemicals, chemical containers that are left uncapped or open, liquid containers stored outside of secondary containers, and waste containers stored in and or near sink areas and floor drains. So next, we will have Mr. Jeric Pascual to summarize everything that we've discussed.
For this summary, we are going to tackle each topics that has been discussed by our group and give you the most important details to remember for safety. In the introduction, we have the objectives of chemical safety, which I hope you guys met at our reporting, and the importance of chemical safety to prevent potential hazards and accidents for a safe working environment. And for the container labeling and postings, its purpose is to determine or to specify the risks of a hazardous chemical and how to avoid them. It also includes how they will be properly stored and disposed, while signages help people to work by guiding them what are the do's and don'ts, and it represents the safety and increase the prevention of accidents. In the health and chemical hazards, for the health hazards, these are the chemicals, physical or biological factors that has negative impacts on our health. It can occur through touch, inhalation, and ingestion. While chemical hazards can cause acute or chronic negative health effects, these chemicals are often found in outdoor and indoor environments like home, workplace, and schools. So the types of chemical hazards are toxicity, irritant, flammable, corrosive, inhalation, ingestion, environmental hazard, and reactive. Safety data sheet contains hazards and safe handling information that is prepared with the requirements of the Hazard Communication Standard. This SDS is a requirement for all personnel to have access to a paper or electronic copy. It contains the safety protocols and the information for all hazardous chemicals used and stored in their immediate area during all work shifts. And for the chemical waste disposal, is just the disposal of any types of chemical wastes, any solid, liquid, or gaseous item that can endanger human and environmental health, which chemical waste needed to be properly disposed to avoid any potential hazards and accidents, like selecting a container for a chemical waste, labeling a chemical waste, and more. And we also need to read the information about its labeled information on how to properly handle chemical waste.